Now we want to look at a little more complicated one with a block on another block. So suppose we have a block of mass 3m. Sitting on top of that is a block of mass m right here. And we're going to come along here and pull on that with a rope of tension T right here. And so I'm going to assume that these again are the same roughnesses, so that the mu's on both of them are the same. And if it's sliding, they both have the same mu k. If they're not sliding, they both have the same mu s right here. And we're also given m, which means this is 3m and that's m. What we want to find, first of all, we're going to find three things. If we pull on that with a rope, what's the maximum tension we can put for no slipping? That is, no slipping there and no slipping there. Okay, and so that's the first thing we want to find. The second thing we want to find is what is the maximum tension for slipping on the bottom surface only? If we pull that harder and harder, the bottom surface is going to slip before the top surface. There's no way that one's going to slip and that one doesn't. So the bottom one's going to slip first. And then the third case is, if we pull it even past that, that means both surfaces will slip. This thing can't keep up with that one. It'll lag behind a little bit. And we want to find the acceleration. We can't find the tension because the tension at that point could go off to infinity. But we want to find the acceleration as a function of the tension for the two blocks right there, for slippage on both surfaces. So in the first case, they're both static. The next case, this is kinetic, that's static. In the third case, they're both kinetic friction. Okay, so we'll first look at the case where they're static right here. Again, here's our forces. We have the 3mg coming down. We have the two normals inward. We have the tension, and we have just friction. There is no friction on that block. He's not trying to slip, so there's nothing to fight. He's just sitting on top of it right here. Okay, so if we come over here and we write out the forces on the bottom block, we've got the tension. I put my coordinate system like this, so we have the tension going that way, minus the frictional force. And since this is not moving, it's equal to 0. The up and down, we have the normal, 1, minus the normal, 2, minus the 3mg, that's also downward, and that equals 0. There's no acceleration up or down. For the second block, the top block, we don't have any x forces. We just have y forces, and all we have is the normal 2 minus the mg equals 0. And then here was our friction. Remember, normally it's less than or equal to, but we're on the verge of slipping. We want to find the maximum tension so that you don't get slipping. So we're on the verge of slipping. So we can make that an equality right there. So from this top equation, we can see that T and the friction are both equal. And from this one, we can see that the friction is equal to mu Sn, 1. Now, we need to just plug in N1. N2 from here is mg. And if I put that into there, that's mg, and that's 3mg. If I put it all on the other side, N1 would be 4mg. So I'm going to replace the N1 with 4mg right there. So there's my tension. There's the tension. That's how hard I have to pull on this thing before either one of these two surfaces will slip. It'll just sit there. Okay. So now we want to pull a little harder. Now it's going to slip only on that surface and not on that one. The only difference is between this one and this one is I'm going to use the same coordinate system, except on this one we add a friction here because this block has to be pulled along this block. It wasn't pulled anywhere before. So there's a friction on that block that's pulling it this way. This block is also accelerating, and so something force has to be pulling it. And if there's a friction there, there has to be an equal and opposite friction, force 2 in red, on the bottom block right here. So the only thing we've added are these two frictions, and we have an acceleration now. And this friction will be a kinetic friction. This friction will be a static friction. So if we go back to our equations, now in the bottom block, we've got the tension going this way. Now we have two red frictions going back. And that equals 3ma because this has a mass of 3m. So this is 3ma going this way. The y force is exactly what we had before. We haven't changed that a bit. the X forces on the blue, now we have an X force, frictional force 2, and we're calling that way positive. We're calling this way positive on both, since that's the way you're accelerating. And then the forces in the Y, N2 minus Mg equals 0. Here's our two frictions. Frictional force 1, which is the bottom one, that's slipping, so it's mu K N1. The top one is not slipping, so it's mu S N2. But since we're on the verge of slipping, that's why I can put it equal right here. Okay, so there's our equation. So I said, okay, from this equation right here, we know that the acceleration is equal to frictional force 2 from right there. I'm going to take that MA that we just got and put it right up into this MA. So we're going to have T minus the frictional force 1 minus the frictional force 2 equals 3 of my MAs. But we just said MA was frictional force 2, so I'm just putting that into there. So if I solve for T out of here, throw these on the other side, I have 1 frictional force 1, putting it on the other side, but I got 4 because that's going to be added to that one, so I have 4 frictional force 2s. So I'm just rewriting it, and I'm rewriting what our frictional forces are. So in place of frictional force 1, we'll put mu K N1, and in place of frictional force 2, I'll put mu K N2, except we have the 4 with that one. Okay, and now I can come back to here. We know what N1 was, and we know what N2 was. Remember, N2 was mg. N1, put that into there. N1 is 4mg. So I'm going to replace N1 with 4mg, replace N2 with mg. Now I have 4 mu kmg plus another 4 mu kmg, so I get 8 mu kmg. So that's the amount of pull, that's the maximum I can pull on this rope so that this doesn't slip and that does slip. You notice it's bigger than this one. It better be. That we weren't able to get the block moving on this one. Here we are. So this one should be bigger than that one. Now this one down here, we said, what is the acceleration as a function of tension? I can't ask for a maximum tension because that goes off to infinity. So if we just come over to here, they look exactly the same as this one. The only difference is their A's are not equal. Why? Because this is their movement between the two blocks. So A1 and A2 will not be the same. Other than that, all the forces are the same. So if we come down to here, and we're going to plug in the same things we had up above, we have T1 minus the frictional force 1 minus the frictional force. The only difference is there's going to be an A1 and there's going to be an A2 on this one. So the equations are exactly the same. Here we have N1 minus N2 minus 3mg equals 0. It's the same thing we had up here. This is MA2, and that's the same one we had here. The frictional forces are both mu k, since they're slipping on both. And so we have frictional force on both. So now I can say, let's go to this equation and solve for A2. Well, A2 is just frictional force 2 divided by m. So, or MA2 is just the frictional force, but the frictional force we said was mu Kn2, and N2 was mg, so mu A2 is mu kg right here. So it looks like this has nothing to do with the tension. Once you got slipping on both cases right here, or this one down here, an infinite amount of force won't affect this acceleration. This acceleration is now fixed once it slips right here. It's just mu kg. But the bottom acceleration will depend on t. Okay, so now when we want to solve for A1, we can just take this equation and divide everything by 3m. So we have A1 equals t over 3m plus the frictional force 1, which is mu kn1 over 3m, plus the frictional force 2, which is mu kn2 over 3m. So now we can say, here's my t over 3m. We know n1 and we know n2. One of them was 4mg, one of them was mg. I can cancel out the m's, so the m's are gone. So one's just a 1 and one's a 4. And now we can combine these two together. 1/3 plus 4/3 would equal 5/3. So we end up with the acceleration of the bottom block does depend on the tension. It's t over 3m plus 5 mu kg over 3. So you can see If T gets larger, A1 gets larger. Whereas for this top block, no matter how large T was, A was fixed right here. So now we could have put more blocks on top of more blocks, and you'd have more and more frictions in here, but it's still all exactly the same way right here. Okay.
I'll skip that.